Hello, everyone, and welcome to today's webinar, Creating a Safe Post-Pandemic School System. For everybody's information, today's event is being recorded. So today, I think we have a great discussion in front of us. It's a discussion about understanding the role of the built environment in keeping us safe from different kinds of health and climate risks. But in particular, we want to focus on today's discussion is going to focus on a topic that I think is on a lot of our minds, which is what role, how do we ensure that we have safe school systems once we hopefully start opening up schools, and what is the role very specifically that the buildings in which we go to school play in keeping students and our educators safe and healthy. Before I get started with the webinar itself, I just want to let you know that today's event is co-sponsored by Engineers and Scientists Acting Locally and the Architectural Engineering Institute of the American Society of Civil Engineers. I am the founder. My name is Arthi Garg. I'm the founder and chair of Engineers and Scientists Acting Locally, and we are a all-volunteer 501c3 nonprofit with the goal really of just getting more engineers and scientists engaged with their local governments and local communities. So we put on events like this. We have a lot of resources on our website. We have a lot of great organizations and individuals that we feature on our website, on our blog, to help you understand what you can do as an engineer and a scientist to make a difference in your community. I'm now going to hand things over to Rosamond Ho. Rosamond is a volunteer with ESAL. She's also a recent graduate from Stanford with a bachelor's and master's degree in mechanical engineering. During her time there, she looked at the role of the built environment, specifically the use of natural ventilation systems to reduce the rate of infectious diseases in Bangladesh. And she also co-founded and was the president of the Stanford Science Policy Group. Rosamond's going to tell you a little bit about AEI and about our great panel that we have today. Thanks. Oh, and actually, before I hand things off, I just want to encourage everyone, please share your name and where you're joining us from in the chat. And please also use the Q&A anytime during the discussion to add questions. And there will be a period where the panelists will answer audience questions during today's event. Take it away, Rosamond.
Oh, sounds great. Thank you so much for the warm introduction, Arthi. And yeah, before we start with the panel, I'd like to talk briefly about the Architectural Engineering Institute, who is co-sponsoring this event with us. So the Architectural Engineering Institute is an organization for architectural engineering, and it provides more than 8,000 members with technical information, professional advocacy, continuing education, and other opportunities to excel in their careers. And they were created to promote an integrated, interdisciplinary approach to planning, design, construction, and operation of buildings by encouraging innovation, collaboration, excellence in practice, education, and also research of architectural engineering. So if you would like to learn more about them, feel free to visit them on their website. So as you know, with this panel, this is a very important and timely topic right now, and especially given the state of schools all over the country. There are a lot of questions as to how do we keep schools safe throughout the pandemic. And so today we have three amazing panelists who will be here to talk more about the initiatives from a built environment perspective on how schools have been dealing with the pandemic, and also perhaps what you can do as well to help your school board with implementing policies that will keep students and educators safe. So we will be starting off with panelist self-introductions, and we can start kicking it off with Bruce, if you would want to introduce yourself, and then we'll move on to Stephen and then Bo.
Well, good afternoon, everybody. I'm Bruce Lindsay. I'm a professional engineer and a certified energy manager. Recently, I was the manager of energy and resource conservation for Brevard County Public Schools. It's roughly 75,000 students, 84 buildings, 13 million square feet. I also serve on the ASHRAE Epidemic Task Force, and we're trying to develop recommendations to reopen schools and to enhance design for the future. And I'm also president of our local ASHRAE chapter here in Florida. Back to you.
Cool, sounds great. Thank you so much, Bruce. Yeah, we can move on to Stephen now.
Great. I'm Stephen Ray. I'm an associate director at Skidmore, Owings and Merrill here in Chicago. My background's all mechanical engineering. I got my bachelor's, master's, and PhD in mechanical engineering at MIT. And after that, did a little stint in academia while also working at Skidmore as a consultant. I started a small engineering program at a liberal arts school here in Chicago. And then a couple of years ago, shifted full-time over to SOM, where I help lead the high-performance design team on projects all over the world. I'm also quite involved in my kids' school and in their district in helping to reopen. They're all in person now safely on their health advisory team. And quite involved with ASHRAE as well. I'm currently a voting member on SSPC 62.1. That's the committee that writes the national standard for indoor air quality. And I'm a member of a subcommittee of the epidemic task force, the commercial building subcommittee. And then lastly, I am an advisor and was previously on the board of a charter school here in Chicago. And so this event is actually great for me. It really blends my love of the built environment with my love of education in schools. I'm happy to be a panelist.
Cool, sounds great, and happy to have you here too. Yeah, so we can finally, last but not least, of course, as Bo, take it away.
Yeah, hi, my name is Bo Hammer. I currently live in Wheaton, Illinois. My wife and I just moved out here from the DC area. I'm a physicist by training and have spent most of my career as an executive in the nonprofit sector. And I think the reason that I'm on this panel is that I spent 2 terms as a school board member when my son was in grade school in Haddon Heights, New Jersey, when we were living outside of the Philadelphia area. And so I come to this panel from the perspective of how a school board member and obviously a parent might approach some of these issues. And also a person who brings a scientific perspective to lots of policy questions.
Cool, sounds great. Thank you so much for that. And so, yeah, so just to go over a little bit of what the structure of this talk will be, we'll first start off with some initial panel questions to get the talk started, to touch a little bit on every aspect of, whether it's the ASHRAE Epidemic Task Force, whether it's, renovations and facilities from a school board perspective, and other ways to get involved. And then after we finish the initial panel questions, we will also have some time for the audience Q&A, at which point feel free to use the Q&A function and raise your hands, and I will be fielding the questions. And of course, if you do have any other Q&A questions during the initial panel questions time, feel free to leave it in. And I will do my best to try to use this function. This is my first time moderating, so please forgive me if I take some time with technical difficulties and things. But yeah, so I'd love to get started off with one of the first panel questions about what can schools do in the short term to help with school districts who are doing in-person schooling. And so we can start off with anyone who wants to go first. I think this is an open free-for-all question. So yeah.
I'll go ahead and jump in since I've been involved in it for a while. And this is basically recommendations coming from the Epidemic Task Force. Number one, HVAC systems in schools are very complex. They're very different. You go from weather zone to weather zone, they're gonna be completely different. And the key is to either remove the virus through filters or dilute the virus through outside air. And you really need to get an HVAC engineer to come in and do a pretty thorough assessment to determine how good the HVAC system is. I would give it a letter grade, A, B, C, D, or an F. And those schools are getting Fs. They should not be occupied, period. Those that are A's, fine, let's go. And those that are in between, you got to fix them before you let the kids back in. Relatively straightforward. The key thing that the task force is saying, put in filters. Not just any filter, at least a MERV 13 filter. MERV stands for minimum efficiency rating value. You can look at HEPA filters, but they're much more expensive and require a lot more energy. You can't put a MERV 13 into every HVAC system, but you can try. There are a whole host of standalone HEPA scrubbers that you can put into a classroom, and we're seeing a lot of people use those to try and achieve some cleaning of the rooms. And then my most concerning issue is the nurses' station. That's the worst place for contagion. You don't want to park a sick kid and the nurses next to a bunch of other people. So you need to take special precautions on your nursing station and make some modifications.
Can I ask a question about that?
Sure.
So a lot of these sort of specs and standards seem rather expensive. And a lot of school districts, obviously, as you know, struggle with resources. And I've always been curious about kind of low tech, low cost alternatives to like refiltering the built-in HVAC system. And I was just like reading the most recent issue of Science Magazine, and they were talking about measuring indoor CO2 levels as a proxy for approximating, I guess, air exchange and potential presence of virus particles. What do you think of that?
I think it's viable. However, there's some issues that get in there. We're going to have a much lower occupancy in a lot of the classrooms. And so the CO2 levels should be coming down regardless. That doesn't mean to say that you've reduced the exposure risk. All you're saying is you're just having fewer kids generating CO2. If you're at full capacity, that's a different story. You can look at that from that perspective. But the big one that people are using is just run the air conditioning for 2 hours before occupancy, run it 2 hours after, and that's a 45% increase in your energy bill, but it's gonna at least purge the area and should reduce exposure.
Yeah, and you know, I have an anecdote to share, and then some other kind of broader perspective. An anecdote to Bruce's recommendation to bring in an HVAC professional is I've personally inspected some buildings just of other friends' parents' schools, and you know, they have had someone come and help them over the years, but that person inadvertently has completely shut off the indoor the fresh air supply to those buildings. And so there's no outside air coming to these buildings. And some of these are brand new buildings, right? Built within the past 5 years, great HVAC systems. But, you know, a volunteer was meaning to help, but actually made a very substantial change that, you know, hurt them before the pandemic because, you know, a lot of kids would get sick there. The flu would go through like crazy because there was no ventilation. And then with the pandemic, it's even worse. But back to the question, the way we've approached it, and I think this is consistent with the CDC and the ASHRAE guidelines, right? So the first thing I recommend is just Google CDC school guidelines or ASHRAE school pandemic guidelines, and you'll get these guidelines that are quite thorough. You know, Bruce and other members of the ETF have all contributed to that, and it's based in pretty sound science. So read through those and familiarize yourself with all that's in there. You know, to Bo's point, you might not implement all of those, and that's where I think some discussion with you know, an HVAC professional or just some more searching online can help you prioritize some of those. I think another helpful strategy beyond just the HVAC system is thinking about your school with kind of 3 zones of protection, right? The first zone is keeping the virus from coming into your school, right? So that's where you want to keep an eye on community spread. That's where you want to do symptom screening of everyone coming in, maybe temperature checks, other things, just to try to keep the virus from actually coming in within the school. Then the second layer is keeping whatever virus might come in isolated to a cohort, right, or to a pod. And so how do you create cohorts? How do you keep those cohorts separate? Hallways often get very low ventilation and might be crowded, especially if you're all transitioning between classes at the same time. So that's one of the worst places where you could have cohorts spreading one virus to the other. So how do you isolate the cohorts? And then the third layer is how do you reduce transmission within a cohort, right? Often that's within a single classroom. And I think it's helpful to keep in mind, how is this transmitted, right? Often it's through, droplets or aerosols in kind of the close range, right? That's why there's 6 feet recommendation. In other places, it's 1 meter, 2 meter is so important. And the more you can separate your desks, you can have, sneeze shields, the better you are there just pass it, because that's the primary mode of transmission. There's also fomite transmission, right, where it gets on a surface and then you touch that surface and then you bring it into your respiratory system. So the hand washing, the surface cleaning helps really to reduce that. And I think the science is increasingly saying that's not seen as a primary mode of transportation. Yes, it can be transmitted that way, but that's not often the main mode. And the third one is, kind of long range aerosol transmission, right? So you have these aerosols that go into the air, and if there's enough of them, then you can transmit it that way. And there's some cases where people are in an enclosed, non-ventilated place where that's happened. There's some examples on school buses. There's quite a few studies out there on this long range aerosol transmission. A lot of those happen in very poorly ventilated places where people might be singing or eating or doing other things where they're unmasked. And so, I think keeping those modes of transmission in mind for this third layer, right? How do you reduce transmission within a cohort is helpful. And we've been very strategic in addressing each one of those 3 layers of protection, and really trying to communicate that with the community.
Cool, awesome. Yeah, thank you so much for laying out those different layers to battling the pandemic within schools as well. And I just briefly wanted to answer a Q&A here where Sam asked, what are the downsides of using 100% fresh outside filtered air in the buildings?
Bruce mentioned that, right? It's largely cost, and it depends largely on your climate, right? So if it's really nice outside, you're not conditioning too much, not so bad. Some systems you won't be able to bring in as much outside air if you just do outside air versus if you're recirculating that. And if you're recirculating through a MERV 13, we've seen some research that even recirculating through, lower efficiency filters is still beneficial, right? So if you can get higher air changes, even though it's not 100% outside air, and you have good filtration, that might be better. But largely it's just cost. Running your fans and having to replace your filters more frequently, conditioning whatever air is coming in if it's really hot or really cold outside.
The other side of it is your HVAC systems are designed to meet minimum standards, and everything is just down to the absolute minimum. And you don't have the ability to expand and bring in more fresh air unless you replace the fans or increase the ductwork or do a lot of major modifications that no one has money for. You can open the windows, but I'm down here in Florida. That's not an option until this week. Up north, you open windows and you're going to have ice and snow coming in all winter long. So there are trade-offs.
And I'll note another point here. This might come up later, but it's important in the actual operation of these systems. I've seen plenty of schools that have just a packaged unit up there, and they say, look, we had an HVAC guy come in, balanced it. We have a lot of air. We're meeting, 5, 6 air changes an hour. We have MERV 13 filters. However, the control is set such that the ventilation air is only coming in when that system is on. So during the fall, when it's pretty cool outside, you don't have to heat or cool the room very much at all. There is no fresh air coming into those rooms unless you change the operation of that system. And so another reason why it's important to have someone who knows what they're doing out there to ensure that, you don't just have the system provide all these great things when it turns on, but you want that fresh air coming the entire time that room is occupied. And as Bruce mentioned, you want to flush it out often before and after occupancy as well.
Yeah, that makes a lot of sense. And another question did just come in about this as well. Does the amount of relative humidity affect positively or negatively the indoor transmission of pathogens like COVID-19?
there's been a lot of talk about a range. You don't want to have too much humidity. You don't want to have too little humidity. And most of the systems that we design as HVAC engineers, we try to maintain at 75 degrees between 40% relative humidity and 60%. You bring in more fresh air in the middle of the summer, you're going to see your relative humidity skyrocket. You're going to have uncomfortable kids, and you're going to have some problems. You try to bring in or increase the amount of humidity in a school in the frozen north, and you're going to have major problems with moisture collecting inside the exterior walls. There's a lot of trade-off here. And again, you really need to have a HVAC engineer take a look at your options and see what your system can actually accommodate.
Yeah, and just to add to that, if you just strictly speaking into the science and the survivability of COV-2, right, so how this virus is transmitted, if you Google DHS COVID calculator, they have a calculator both for surface and for airborne virion, where you can put in those conditions, right, the temperature, the humidity, and the UV level, and it'll tell you what the half-life is, right? So you can put it in and say, hey, 70 degrees at 20% RH, how does that half-life compare to 70 degrees at 40% RH? And it'll tell you what it is. But to Bruce's point there too, that half-life is often way, way longer than the air changes you're going to be getting with most ventilation systems, right? So yes, strictly speaking, there is an influence. The more humid you get, often the lower the half-life is, right? So it's gonna die off faster in some of these more humid spaces. But if you go to the calculator and you can look at those hours or the minutes even for that half-life, the air changes is often going to probably get you more than that increased humidity, and then you avoid some of those costs and other kind of logistical challenges, especially in colder climates.
Yeah, that makes a lot of sense given the large amount of difference in humidity, and also like daytime and nighttime like temperatures and humidity like for different parts of America. So definitely very useful to keep in mind. Well, now that we've been yes, Bo.
Quick question on that, because I'm kind of interested scientifically. I think maybe the questioner was also asking, like, how does aerosol transmission, how is that affected with relative humidity, like the persistence of droplet size and aerosol trajectories and stuff like that? Not just virus half-life.
Sure. To my understanding, when it's really dry and you say you sneeze, you have all these droplets, right? There's a large gradient between the moisture content of the droplet and the dry air. And so the droplets evaporate more quickly. And so they more quickly become aerosols, which are suspended more within the air. If you sneeze in a humid environment, those droplets can't evaporate so quickly. And so those droplets are likely going to, fall faster to the ground, and so not be transmitted quite as easily. So that's another kind of physical driver behind the difference between those.
So does that impact ASHRAE's thinking about recommended relative humidity levels, like during pandemic specific times?
I think the guidelines are to target between 40 to 60% RH. And so that's typically kind of what we get in the indoor environment. Going much beyond 60% RH, I don't think it's going to really meaningfully impact either one of those, either the physical transmission distances significantly, or the half-life. It's going to reduce the half-life, but it's not going to be very meaningful. I think even at 60% RH, it's pretty low half-life. So if you're within that range, I think it's great. If you're in a cold climate, I guarantee you're not at 40% RH in the winter, unless you have maybe zero ventilation air and you have a ton of students in there who are exhaling and adding that moisture. So, I think that's where the question comes in. Do you humidify in a very dry, cold climate? And that's going to depend on your envelope and what kind of issues you might have with mold growth in there. You probably could get up above 20%, right? 30 or 40% in the winter might be okay in some places, but older buildings, 40% in the middle of the winter is probably going to condense and might lead to some moisture problems. So it can get tricky.
Yeah, and you mentioned a little bit about, change with the changing seasons, and since, we've only, for a lot of schools, they've only just started with having like students coming back to school like with this fall semester. But like looking forward, what do you all see as the biggest challenges for balancing the short term and the long term retrofits in the school facilities?
So I don't have an answer to that question, but in terms of short-term retrofits, assuming you can even just like crack a window, do fans help? I mean, again, thinking about this as a parent and a school board member, and maybe, our schools don't have the resources to do either temporary retrofits to the HVAC system or whatever. I mean, are there low tech things we can do until the vaccine is readily or widely distributed?
I'll give a quick shot here. One of the issues with fans is, does the fan actually increase the dispersion of the virus? Does it actually push it around into the breathing space? If we can have directional flows so that it goes away from the students and exhausted, that'd be great. What we're seeing more and more of is a lot of districts are opting to get what we call scrubbers. And that's just basically a standalone fan that pulls the airstream through a HEPA filter or MERV 13 filter and captures it and enhances the turnover of air and cleaning the air. We're also seeing a lot of schools opt for ultraviolet lights, which has been used to control tuberculosis for many years. We're also looking at ionization technology, and we're looking at several other things out there that still require considerable verification, I guess is the best way to phrase it. And let me jump on this. The biggest problem is money, okay? I mentioned ultraviolet technology. These are relatively expensive items to put in, and they're even more expensive to maintain. There are quartz tube costing roughly $300 and they last a year. Put one of those in every classroom in the United States, and how much are we talking?
Yeah, and if I can kind of expand on some of that, often where fans are recommended, it's in an open window pointing outward, right? So the fan is blowing outside, and that helps to bring in fresh air from other parts of the building or from other open windows, and that avoids some of that increased transmission risk because you're not blowing someone's droplets across the whole room, right? You're blowing it outside. Even just cracking windows, though, in a number of buildings can get a decent amount of air coming in there. One of the things that we recommend with those open windows is if you have open windows and you have a bit of strong breeze coming in, that itself could act like a fan, and so kind of a rule of thumb that we've recommended is, if you can put your hand at the nearest desk to that open window, and if you can feel a steady breeze, right, that's enough velocity to potentially move some of your droplets. If you can do that, just close the window some, right? Like you're getting more than enough air into that space. If you're sitting at the nearest desk and you have a steady breeze that you can feel, you're going to have tons of air going through that space generally. And some other low tech options, going back to that, the modes of transmission, right? It's not like there are plenty of places that are not super well ventilated where people have been fine. You have leaders coming out now, even Fauci on Sunday, really recommending students to go back to schools, and that's to schools that have a variety of ventilation capabilities. So it's not just through the ventilation system, right? Like the spacing of desks, how those desks are facing each other are also very low-tech kinds of solutions. And another kind of low-tech scrubber that I've seen some people put out there. I haven't seen a study on it yet, but homemade MERV 13 scrubber where you get a MERV 13 filter and you have a fan that pulls air through it. It reduces that flow rate, but it's pulling air through a MERV 13 filter. And so in my mind, even that is going to be better than nothing if that's all you can afford. Just ensuring that air is not going to be blowing at someone who might then spread, droplets or aerosols right into someone else. So maybe in a corner that's pointing away from people, but that itself is going to help to scrub some of the air better than nothing else. So I don't think it's you need a $500 HEPA filter or that's it. Getting some air changes, cracking a window are other ways that you can kind of flush out those aerosols, in addition to those other very low tech and very effective social distancing, masking kinds of measures you could take.
One of the other concerns with talking about putting scrubbers in, what other type of additional equipment is noise. We are in classrooms. It's absolutely essential that we have low background noise so the kids can comprehend what's going on. And you put a fan in there and you crank it up and all of a sudden the teacher can't be heard back in the room. What's the point of having the kids in the classroom? And again, this is something you have to maintain. You have to, you're going to be taking this item that you have to change the filters on a frequent basis. You got to train your staff to do it safely. You have to have funds to do it properly. And this is just one more thing that there's no budget for. And who's going to do the work? Are you going to have the custodian do it? Are you going to have the HVAC technicians do it? You're going to have an outside contractor do it. And those things are the real bugaboo in all these activities.
Yeah, no, that makes a lot of sense in the terms of, who are we going to get to work on these retrofits and within the facilities. So I just wanted to ask a question that was asked here by Sam. So if there was a system that provided 100% conditioned outside air that significantly minimized thermal transmission through the building envelope, would the panelists be interested if it can be retrofitted?
I'll jump in real quick. Right now, most new schools will utilize dedicated outdoor air systems to supply the minimum ventilation required for the school according to code. You have a rooftop unit sitting on top of the roof. It's ducted to all the classrooms. There you go. Got all the air you need. You want to retrofit all the schools we have out there with that system? That's a monumental task.
Aren't these filters, the traditional HVAC systems, aren't they designed to filter the air coming from the outside rather than the air from the inside? Or are they filtering in both directions?
Again, if you have a dedicated outdoor air system, you'll have filters on that. And if you're bringing fresh air, which is supposedly clean air, you don't need to have a filter on that. The other systems, your air handlers, will have filters inside which are intended to capture dust, pollen, viruses, and bacteria. And that requires a much higher level of efficiency.
Yeah, and so both, some systems only filter the outside air, right? Those dedicated outside air systems. Other systems, if it's a recirculation system, a VAV, often these packaged units are just taking a lot of indoor air and circulating it around, and maybe they mix in a little bit of outside air. But all that recirculating air in those systems goes through the filter as well, and that's what we're saying. Those high efficiencies are effective. So again, it depends. And frankly, I think a ton of schools don't have any ventilation system, right? So I see a comment too about buildings from 1938. We've worked with buildings here that are built in the early 1900s, and they don't have ventilation air, right? So, that's where it really comes down to trying to find a way to crack a window. If you can afford some of these air scrubbers or these lower tech air scrubbers, that's a way to get some kind of ventilation in there. But again, I just strongly encourage you to keep in mind, so much of the evidence that I've seen of the primary mode of transmission is this close range kind of droplet aerosol transmission, right? Where you're in this close range. And so if you're going to do anything, making sure you can separate desks as much as you can, trying to limit that kind of interaction, have masks on as much as possible. If you're eating lunch in the classroom, separate, have sneeze shields so that if someone does sneeze or cough when their mask is off while eating, it's reduced. Try to minimize the time to eat. Don't talk when you're eating, right? The amount of the virion that you emit is a function of your activity. So if you're just sitting there breathing, listening, you're emitting much less of this stuff than if you're actively talking, right? You're emitting less than if you're singing loudly, right? And definitely less if you're sneezing or coughing. And so if you have an effective symptom check, right, where people don't come into your classrooms who are actively sneezing and coughing, that's going to reduce the amount of virions produced very, very dramatically. So then you're talking about people who are either talking, singing, or just breathing. And that really reduces the amount that you're going to be emitting, the number of aerosols and droplets that you're emitting to space. So I just encourage you, don't just write off, hey, this is an old building, can't do anything, right? Think about some of these other kind of policies that can really get down to how is this thing transmitted and how can we reduce those primary modes of transmission. Even if we can't revamp our whole HVAC system, you can probably do tons of things to mitigate the primary mode of transmission.
So this is really fascinating. So like from a school board policy and school procedures perspective, really the first thing we should be worrying about is whether people are rigorously masking and managing the flow of students throughout the building and keeping pods isolated. All these things you've been saying are way, way, way more important than spending hundreds of hours and hundreds of thousands of dollars worrying about HVAC in terms of managing relative risk. Is that a fair?
I think so. Yeah, I think so. I mean, and another resource that's helpful, and he's by no means the end all be all on this, but if you Google Steve Taylor COVID-19, they put out a white paper. Steve Taylor is well known in the industry. He chaired SSP 62.1 for a number of years. Has a firm out in California. And he pulls a lot of information onto this white paper. Again, Steve Taylor, Taylor, COVID-19. And at the bottom of that, he has some recommendations based on the mitigation effectiveness and also the first cost impact. And again, he's a mechanical engineer that's selling mechanical engineering equipment, right? So even coming from him, though, if you look at this, the top three, all have to do, and actually, let me see, I think I might be able to share this just briefly here. Yeah, so like if you just look at these top three here, a lot of these come back to what I was saying, right? Understanding how it's transmitted, how can you implement policies to reduce some of that transmission, and often they're very low costs. Even here, he lists some of these mechanical solutions that we're describing down towards the bottom. Again, coming from a mechanical engineer himself, who's well respected in the industry. So a lot of these kind of policy type things, masking, social distancing, testing, symptom testing, use computer video where not needed, or sometimes like, how do you engage specials, right? So teachers who are teaching, language, music, gym, those kinds of things, where they might be transmitting between cohorts. Maybe those particular modes of instruction are hybrid or further distant than your homeroom teacher who's with the same cohort the whole time. So that's coming from one person, but someone who's well respected in the industry and also has a vested interest in getting HVAC equipment out there, is recommending that these policies can be very effective at those primary modes of transmission.
Yeah, that makes a lot of sense. And thank you for sharing that link on. Drop that link off to that. That would be great. Let's see. And we have an open question here. That says from Chris. That says, I work mostly In low-income developing economies, where schools do not have any HVAC system but may rely on passive ventilation or some operable windows, would a room-level fan and filter combination be useful in local scrubbing of air to reduce the amount of the virus particles in the air?
You know, Bruce, we could probably answer this in tandem, but I would say if you're in a climate where you can naturally ventilate, right? You can open a window and it's nice enough outside where you can just have that air come in and come out. That's probably going to meet your ventilation requirements on itself, right? So if that's possible, that's great. If you're in a climate where it's very cold or it's very hot and humid, where you really just can't open the window to allow for that passive ventilation, that natural ventilation, then yes, I think some kind of air scrubber, whether it's an off-the-shelf kind of HEPA or MERV 13 scrubber, or if it's maybe a lower tech solution where you can find some stuff online that's lower tech and cheaper, would make sense that you have to seal that room up, but still want to have some virus removal from that scrubber.
Yeah, thank you for answering that. And so, yeah, we talked a little bit earlier about, the school policies and what may go into like the current retrofits versus like more long-term retrofits. This is more, I guess, of a question fielded for Bo. But maybe we could talk a little bit more about the school board policies and, just to fill in folks here about what is the timeline like, for proposing or writing or passing these like short-term retrofits legislations or policies for school facilities renovations?
So my experience is based on being on the school board in the early 2000s, so way pre-pandemic. But we did have experience with a major funding for major construction and reconstruction of our 4 school buildings. And the timeline, because this involved passing a bond initiative, and so the timeline is on the scale of a year, and then just for the funding issue, and then construction is on the scale of a year or more from design to grand opening. So that we're talking years time scale for major school construction. I can't talk about what's involved in school retrofits, but my gut says that for a major school district, any sort of system-wide, either new construction or major system-wide retrofitting would, in my sort of gut experience instinct about it, is way beyond the time scale of a pandemic. And so what do you do with that? And that's why I keep harping on sort of low tech, low cost classroom and building scale solutions, and the kind of stuff that Stephen is talking about with sort of more behavioral interventions rather than systems interventions.
Yeah, that makes a lot of sense.
Second, what he just said. Organizing the funding for a major program is a 1 to 2 year effort. And we just went through a 6-year facility renewal program to just change out the building automation systems in our schools. And it takes an entire year to actually put it in place. And we have to phase it over the 6-year period because we have so many to go. And what people aren't aware of is the labor shortage and the skilled labor shortage that's out there, and the lack of vendors right now to meet this amazing demand for new equipment.
Yeah, and I know I've read that New York Public Schools deposit just said they're going to reopen I think next week. I read how they basically got a scrubber, for every single room there, and that kind of policy I think is one that does have some legs if you can afford those scrubbers or cleaners, and you can get some that are quite effective for $200 on Amazon, right? So you could get some that are $1,500 plus. You can get some off the shelf that are $200, and they go down from there if you start to do it yourself. But even $200 a pop, you might be able to get a little creative and getting that into most of those rooms in your school. And it's literally just something you plug into the wall and you put in there. You do want to make sure that with those that you're actually cleaning enough of the air, right? Just getting like you can get a really cheap small one that's meant for like a personal office. That's not going to do much in a whole classroom filled with a bunch of students, right? So you do want to make sure that you're getting roughly 2 air changes with that HEPA filter for that room. And, you know, if you Google that, a lot of them have this CADR rating, the clean air delivery rate. And you can Google, you know, how much air change am I getting for my filter? Like air change from CADR, it's not complicated, but you can find how to ensure that you're going to get that based on the square footage of your room and the ceiling height of your room. So I think that is one that if you can find the money for that, it's easy to put in there at a very large district scale. Obviously, the infrastructural stuff is easier, can be quieter if you can afford it. You know, another one that I think is worth considering if your school does have an HVAC system is looking at switching out MERV 13 filters, right? Not everyone, but a lot of these units, you can just take out the existing filter and put in MERV 13. They're not that much more expensive. And, you know, so that is another one where it's not a huge infrastructural change, and that increased filtration efficiency can go a long way in helping to pull out, especially those aerosols that might be in the room when you're recirculating the air, you know, through air handlers.
Yeah, and I think, I mean, so big, expensive, short-term solutions don't seem kind of feasible to address something on a pandemic timescale. But, you know, I think it's also important to think about sort of long-term planning. And to me, one of the lessons learned about this pandemic is that a lot of what we're suffering from is due to a lack of planning or discarding plans that were once in place. And so from a policy perspective, thinking about how we might deal with this in the future, a lot of the things that we're talking about are also just generally good for the quality, the indoor air quality, which is good for student and staff health, regardless of whatever the current health situation is. And one of my concerns about, and I think Bruce mentioned this, is, you know, if you're going to have classroom scale scrubbing, that's likely adding to the noise in the classroom, which is also a health factor and impacts learning. And so I think that we should, to the extent that I've been harping on sort of low cost, low tech solutions, those also have their downsides. And so as we're coming out of this and school boards are thinking about sort of how we recover and how we think about the future, I think a lot of these recommendations for quieter or, you know, building scale HVAC fixes are worth thinking about it, because, you know, school districts are always, you know, upgrading their systems on a planned out time scale anyway. So we have all this great new information, and it would be important to fund, you know, to budget and plan for it.
Yeah, that's very true. And we do have someone with an school investment infrastructure related question. The person asks, investing in public school infrastructure has been a topic of discussion for a long time. Has the pandemic changed the priorities in school systems with respect to deferred maintenance in general?
I can briefly chime in. I don't have access to, you know, major school districts to comment, you know, broadly or you know, statewide or even nationwide level at all. But I can say that in a few of the schools that I've personally been involved with, so maybe half a dozen, that it absolutely has shifted the focus, and people have brought, you know, some of them have hired contractors to come in and do kind of a preventative maintenance now moving forward. You know, so anecdotally, yeah, from my experience.
I'm going to come back and say it's not my experience. We just passed a referendum in November to put roofs on the buildings. We're in the middle of a pandemic, and our focus is on roofing. We're also putting more paint into the schools. Part of that's because we have updated some of the HVAC systems in the past 6 years, but in the middle of a pandemic, I think some of the priorities are short.
Yeah, that's definitely very interesting to hear sometimes some of the things that come up in the middle of a pandemic with relation to schools. For personally, for me, in terms of with my local school district, there have been talks about like broadband, like someone also mentioned in the comments here, like broadband quality, how do we get access and help that, and also mental health for students as well who are now locally locally, or sorry, learning at home. So I guess that's a whole other topic for another talk. But yeah, I mean that was a great segue into talking a little bit about how has the ASHRAE Epidemic Task Force been working together with school districts to implement safety protocols or other things. And I know we've of course mentioned quite a bit of things before, but if there's anything else that the panelists want to talk about in relation to school districts and school boards and connecting with that, feel free to talk more about that.
What we've done on a local level, hold on one second. Thank you. We've reached out as a task force to different state educational departments. I know that I reached out to the Florida Department of Education, made them aware of the ASHRAE COVID website, make sure that their engineers are aware of it. They can contact me, they can contact other members of the task force. And I think the biggest issue that we have done is the focus of CDC has been on sanitation as a primary path. And we have at least made airborne transmission an issue, and they are now considering it as an important element. But again, it's sanitation, it's masks, it's social distancing, and airborne transmission has a role down the road.
Yeah, and I'd add to that, what else is the task force doing? And I guess before even adding that, just want to note that everyone I know on the task force is acting in a purely voluntary capacity, right? And so a number of the people I know, they're burning the midnight oil, they're working over the weekend to put together these guidelines. And so even that alone, meeting, discussing, staying up to date with the latest of the science, and then developing guidelines, that's a huge lift for a lot of volunteers, right? And, on top of that, several of them are, maintaining some kind of media presence, right, to increase awareness around the guidelines. And then, as Bruce said, there's some direct reaching out to districts. I've seen some members give public testimony to some school districts as well. But those are the main ways. It's primarily, a lot of the work goes into the guidelines. And then so I think increasing awareness around those guidelines, because they are quite thorough and based in a lot of sound research.
Yeah, no, thank you to, of course, all the volunteers, the ASHRAE Epidemic Task Force for, as you said, burning the midnight oil and getting all of this done, and instructing and informing schools about this. And now that there's like a new announcement about the recent vaccine, some people are saying that the pandemic might be over by spring or early summer. Well, how can schools best brace themselves for at least the next quarter or the next semester in early 2021? There might be some let-ups of people are like, oh, it's almost done, it's almost finished. But yeah, do you have any suggestions or advice for schools?
I would just say stay vigilant along the lines that Bruce and Stephen have been talking about. The easy sort of school policy and procedural, like relatively easy, very cheap, or relatively cheap things that they've been saying about distancing, masking, flow of students throughout the building. I mean, those are, I think it's really important that they've been talking about those things.
Yep, sounds great. Sorry, Stephen, I think you're muted.
I would say, along with staying vigilant, and this is a broader point, but it's appropriate thing to share now. I can't stress enough the communication with constituents, right? So that's with administrators within the district, but then also within your school. That's with the staff within the school. It's with all of your parents and with the students, right? They're very different kinds of constituents. And I think managing expectations and keeping all those groups up to date with what the strategy is, so what is that strategy based in, is really important, because it doesn't take much to go online and find very different views of the pandemic and very different views of the safety within the schools. There's a lot of voices out there, and understanding that all these different constituents are going to be listening to all these different voices, and they might be conflicting what your strategy is, or the sciences or the policies that you're basing your decisions on. So having very clear and regular communication, I think, with those constituencies is extremely important. And to Bo's point too, I don't think really anything changes in the near term. What's recommended to be safe now is is still recommended moving forward, and just continuing to keep at that, I think, is important. And especially, I guess, especially those lower tech ones, right? Like the ones that don't have a huge cost and that are already working, especially if your school's already doing these things, like just keep at it. We'll get through it. A lot of people have adjusted already. Sorry, Bruce, for jumping back in there.
Not a problem. My issue would be on priorities, trying to maintain the priorities that we already have gone with. In our district, we have 52% free or reduced luncheon. We have a very large low-income group, and we have to provide breakfast and lunch for those groups. And that has been a logistical nightmare. How do you make that happen? We are going to continue to do that. We have a very large special needs group, and we've been able to use our portable classrooms and really focus on taking care of our critical needs, special needs students, and provide the one-on-one teaching they need. And most importantly, we've given the parents the option of either going to brick and mortar schools or online learning. And I think as long as the parents have that as an option, we're good. What we've seen elsewhere is where all of a sudden it's the kids want to get back in school, the parents want the kids to get back in school, and we just need to continue those priorities. And we have to address the maintenance issues to ensure that if they do decide to go back to school, the surfaces are clean, and if there's any issues, close the school, super clean it, and out we go again.
Yeah, no, and on the note of maintenance issues, we do have a question here that's from Sam that says, it seems that this is a more significant issue than just COVID. Mold and moisture are also significant issues. How do you combine COVID with other air quality issues?
I can just say that one of the motivators, I don't have a technical answer to that question, but when we passed this bond issue in Haddon Heights to do major school reconstruction and various retrofits, one of the main motivators was upgrading our HVAC because of a serious mold issue in the library. I mean, and that actually, it's interesting because people are hyper aware of the health risks of mold in their homes and buildings, and that actually provided us a lot of political. It strengthened our political case to pass the bond major, because then it became a health safety issue for students and staff that everybody's going through the library. There's mold in there. We got to do this. I mean, how do you argue with that in the end?
I see an interesting parallel going back to 2008 when we had the economy collapse. In order to save money in schools, what do? We shut the schools down over the summer. And when we opened them back up in August, we discovered that they had turned green, not a good green. In the pandemic, we've had people who are saying we should run the air conditioning 24/7. I don't think they have any idea what that's going to cost. They actually shut down some schools, like I said, just shut them down, and not realizing the concerns they had with once they reopen them, what are they going to do as far as the water in those schools? Are they going to be tested for Legionnaires and other issues? What's going to happen when your systems have been down for 3, 4, 5 months? And so we had a whole list of recommendations as to what you had to do to reopen the schools. And the big driver is indoor air quality. Mold and mildew, especially where I am down in Florida, is just, it's prevalent.
And again, just to briefly add to that, aside from those issues, you know, having adequate ventilation, having access to light, having, especially in very cold climates where it might be super dry and it's distracting, or it affects other kinds of you know, virus or bacteria transmission. You know, there are other ways that your cognitive performance can be enhanced by an improved indoor air quality, right? It's not just about avoiding mold and avoiding other things, but there are other kind of behavioral benefits to enhance indoor air quality. And you see that more, I think, with an increased interest in wellness, even just beyond just kind of standard health. And another reason I think some of these infrastructural improvements, if approved, you know, have secondary benefits too.
Yeah, that makes a lot of sense. And moving towards a more, I guess, away from more of the technical things about the building retrofits, and talking about, earlier you mentioned getting in touch with constituents, staying like regularly in touch with them. We have a question here for Stephen and Bruce. It says, what are professional considerations for offering technical input in a volunteer capacity? In other areas of policy engagement, like public comments related to permitting decisions, engineers sometimes need to be careful about whether they can represent themselves as engineers based on their licensing status.
I just say, you know, ASHRAE has kind of the typical disclaimers. If you reference any ASHRAE documents that have been shared in the comments here, you'll see those, right? That these are based on the current understanding, and, you know, readers still assume all liability for any injury that might come up. So I think those kinds of disclaimers are still there. You know, ASHRAE lawyers are overseeing all of that. Yes, to public hearings and participation in that kind of a public hearing, or if anything gets into litigation, then you do need to be careful about your licensing status to speak as an expert. But a lot of this kind of guideline discussion and these recommendations, I think, are protected by ASHRAE's kind of typical policies. I don't know if you agree that's accurate, Bruce, or not.
Right now, the recommendations. We also have standards, which are ANSI approved, and those are adopted by local code officials. One thing I didn't realize until I really got involved is most school districts have their own code official, and the code official can interpret the codes any way they want. So it's kind of the wild, wild west out there sometimes. But back to the basic question is, what can engineers and scientists do to get more involved? My recommendation is, where the real shortfall is going to be is in those smaller school districts, in private schools, charter schools that don't have access to the engineering resources that a major district is going to have. And I would really encourage them to focus on that element. I think when I talk to Chicago schools, when I talk to Orlando schools, they have engineering staff on board. They have some of the best engineering consultants available, but some of these more rural schools are really struggling.
Yeah, I just want
they have their own set of problems because of their economics. They really don't have many options to solve the problems.
Yeah, and the school board that I was on was in a relatively small district. We had 4 school buildings, 3 elementary schools, and a combined middle school, high school. And you know, we were okay resourced, but we didn't have a huge engineering staff like Bruce is talking about. And one of the reasons I was encouraged to run is because I was a scientist, and there weren't any issues around science education or anything like that in the curriculum. But I think there's value to having technically trained members of the community sit, be involved in local policy, whatever it is, schools, local environmental issues, or whatever, because I think scientists and engineers approach problems sort of differently. That's how they're trained. And the types of questions we ask to sort of get at the heart of whatever issue is at hand, whether it's a technical issue or not. I think just sort of the mode of inquiry is really important in a range of policy issues, not just during pandemic.
Yeah, cool. Thank you so much for all of those insights. And I guess personally, for me, to ask more tangibly about how engineers and scientists can get involved, we have we have public comments in the school board agendas. We also have those commissions, but those are usually like multi-year appointments. And so how can engineers and scientists from the public, get involved right now as like a member of the concerned public, as someone who's not necessarily like an elected official or being appointed and who doesn't necessarily have like a backing of say ASHRAE, say if they're just like a member of the concerned public?
I got involved because I made noise about a local issue, and then people learned about who I was and said, "Oh, you should run for school board." So if there's an issue you're passionate about, even if it's not an issue that I got upset about, wasn't even anything related to science or engineering or whatever. It was just something that was happening in our neighborhood, and we lived right across the street from the school, and I made noise about it. We got sort of a local ordinance changed as a result, and that's how I got recruited to run. And so, really, if you're passionate about something and it has a policy implication locally, start making noise, get involved, and see where it goes. But at least, I mean, the most important thing, also, particularly during these times when things are so difficult in all different elements of life, is it helps you feel empowered, like you have some control over your life and trying to have a positive influence in your local environment and local community. So it's a really healthy thing to do.
Yeah, no, thank you
And
so much
just to
for
echo
that.
some of that, I think there are a lot of resources available to someone who is technically minded who can go and read some of that stuff, right? So, if you have a technical degree, you might be able to understand some of even these ASHRAE guidelines a little bit better than someone who has no technical background at all. So even if you're not trained in this area, you can find some resources with a couple hours of reading, and then be able to speak with a little bit more authority, that's coming from the work of others.
I'm going to make an outright plug that anyone who wants to get involved, first place they should go is get a little education. I would go to the www.ashray.org/COVID, and it is a treasure chest of information, not just on schools, but on office buildings, on planes, trains, boats, you name it, anything with a built environment, we're addressing it. I would encourage you to look into your local ASHRAE chapter, because I'm sure they are putting on some type of virtual program right now. And this is unabashed plug. February 9 through 11, ASHRAE is having its national conference virtually. And you will be able to hear some of the best speakers talk not only about COVID, but a host of air conditioning issues. Again, being educated, being aware of what's out there and where the resources are is critical if you're trying to influence our elected officials.
Well, thank you so much for sharing that. And we've just shared a link in the chat for the ASHRAE link that you mentioned. And that was a great note to end on. Well, we can have an open Q&A right now for anyone who wants to ask any questions. If you want to ask questions verbally, feel free to raise your hand, or if you just want to ask a question via the Q&A typing chat, that works as well. So yeah, no, the panel's now open for audience Q&A. So I actually did have a question. In terms of, oh, well, there's someone who seems to have a question as well. Okay, so Sam says, I'm an architectural engineer and have developed a building ventilation system since 2001 that actually reduces energy costs. It's a hybrid between architectural, structure, and mechanical systems. Existing buildings can be retrofitted. It uses 100% fresh outside air. Per analyses, HVAC operational costs are reduced to about 40%. Sustainability is improved. Other benefits exist. How do I get the word out?
Mm. Mm. I'll try and give it a shot. I've been working with engineers throughout my entire career. Some have some pretty radical ideas. The question becomes, how does anybody make money with that new concept? And you may find a lot of resistance from the existing equipment suppliers to endorse something that's reduced their cost by 40%. I would encourage you to reach out to your local engineering universities and see if there is a way that they can do a student project that would validate what you're proposing. That's a simple way to get started, and it's always best to have an independent testing lab, whatever, give some viability so you're not just a crazy genius. And believe me, I've been doing this for a long time, and it's not difficult to go find a good professor who will take you under his arm. And if you need any help, reach out to the local ASHRAE chapter. They can also make some introductions for you.
Yeah, that makes a lot of sense. And that's a very interesting point about reaching out to local universities to work together with you on getting the word out. I had personally had a question about school retrofits and school buildings and how, yeah, and how you would be balancing that with like energy efficiency and moving forward. Like how can we design buildings to have that balance between like air quality and keeping us occupants like healthy and safe, but also like being energy efficient.
I'll start with my favorite. We're recommending 2 hours purge before and 2 hours purge after. Well, schools are normally open only 9 hours a day, so you just added 4 hours to 9. So you're looking at about a 45% increase in energy with that simple little thing. If now you want to increase the amount of outside air you can bring in, and we're currently bringing in 15 CFM per person, and we're going to bump that up to 40, which people have been proposing. You're talking about substantial amounts of money, and there are things you can do to reduce that, but you're talking about building a lot more chiller plant. You're talking about having to have much bigger ducts. You're talking about a really significant investment in the building. And then it becomes a question, does it make sense to retrofit the building or build new?
I have a question on that note. Are there any reasonable, passive solutions to take advantage of outside airflow to draw air up and out through the building when there's, on a windy day, for example, sort of hybrid passive active systems, if you live in a windy area, for example?
Yeah, I mean, that's a naturally ventilated building, and that is, feasible where the climate allows for it, and also the controls are there. Some of my graduate work was in natural ventilation, and although I've pivoted away from that, now I can tell you, having commissioned a few commercial naturally ventilated buildings, the operations are tough. With schools that have a lot of first floors, security is tough. Noise can be become a challenge as well, depending on especially in urban cities, urban schools. So it's not without challenges. I think some of, to Rosamund's question, you know, one strategy, and folks have looked at this, is if you're in a very nice climate, it makes more sense to bring in outside air more. But if you're in a more extreme climate where it's really cold or really hot, you might actually get more ventilation effectiveness by recirculating more of the air, still providing the minimum that you need outside, but recirculating with higher filtration. And again, it kind of depends on what you're trying to pull out. You know, and there's some discussion even here. There are some air cleaners that will remove a lot of VOCs and indoor particulates, but they won't remove CO2, or they won't remove some other contaminants. There's actually some very fierce debate within ASHRAE 621 related to how do you evaluate these air cleaners and some of the claims that they have. There's not a standardized process in the same way that there is to evaluate some of these media filters, right? At MERV 13 or MERV 8 or whatever else. And it's a highly debated issue, you know, threats of litigation coming into some of the standards that are being discussed and proposed. But not to go down that rabbit hole, I share that just to say that there's kind of active discussion and debate about, you know, what are we trying to clean, and what are we trying to provide with our indoor air? And you know, there are some solutions out there that provide very little outside air, but still claim it's good indoor air quality. What are you controlling for? So I think the solutions are specific to climates and specific to, you know, the challenges that you face where you are. You know, looking for those kinds of passive moves is important. You know, there are other kind of passive architectural moves to help reduce some of the solar heat gain, for example, and not having to cool as much can be helpful. But another point that I think is more difficult to quantify, and the EPA commissioned a large study about, I don't know, 2 or 3 years ago on this, is, you know, what's the monetary value of having better indoor air, better indoor environment, right? So not just air, but a better indoor environment. You know, it's hard enough, I think, for companies to try to quantify that. When you're thinking about a school and the educational environment for children in the country, you know, what's the added value of having a better performing schoolroom? I think a lot of people only see HVAC moves or building retrofits as costs, right? I have to pay first cost now. What's the ROI? How much energy am I going to save over time? It's very hard to include what's the educational benefit there. Personally, I think there is one. I don't know the best way to quantify that, and I don't know, you know, who best puts that bill. You see companies doing this. Again, there's a huge push with this kind of wellness drive in the broader architectural and built environment communities right now. You see a lot of the most profitable companies spending a lot of money on ensuring their workers have the best place for every single task that they're going to do. They're recognizing that they've monetized it somehow, and they're investing in that. I haven't seen how that translates to the public policy side when you're talking about public schools and who's going to pay for all of that benefit. But I think it is something real and something worth advocating for those in those kinds of positions.
I mean, sort of analogous to air quality is like Bruce was saying about the sound environment in a classroom. And I think there's been some studies done on how noise affects learning. I recall seeing something from the American Acoustical Society about this, or the Acoustical Society of America. And there might be some studies there. And so, but I think it would be really interesting to see some learning studies on indoor air quality or the effect of health on learning, because air quality is certainly related to health. And there's a public cost to both bad health and bad learning. So there should be some sharp economists and educational researchers out there who can collaborate on this kind of stuff.
Yeah, that makes a lot of sense in terms of the noise pollution and the air pollution as well. Yeah, we do have a question here. It says, from Samir. I apologize if I mispronounced your name. A lot of the new and renovated schools I've designed in the Washington, D.C. area utilize dedicated outdoor air systems for ventilation and variable refrigerant flow systems for heating and cooling. Would it make sense for these schools to turn off the VRF units during occupancy to reduce chance of transmissions by these units at the cost of less than ideal comfort levels?
I will come back in and say you don't want to make students uncomfortable. Period. They will not learn. They will walk. Every time we lose a chiller, you might as well just send all the kids home. So turning off your air conditioning systems defeats the whole purpose of having them in the building in the first place.
And I would add to that, yeah, comfort's huge. And though, think about how that VRF system is going to increase transmission, right? Going back to those layers, is that, is the terminal unit, is that just within a single classroom, right? And if it is, that's great. Is the concern that it's just going to mix the air more within that classroom? And if so, are there ways that you can, adjust the damper so that it's not blowing directly on somebody, but instead it's just generally mixing the air in the room? If that's the case, it's probably fine, right? If you have a jet blowing directly on someone, that's where it's going to, enhance the transmission of a particular aerosol cloud. Some VRF, you might have some kind of small filtration in there, and so that, again, that would probably help you a little bit. So I think it just kind of comes down to how is it going to actually impact the transmission. Just saying turn the VRF off, blanket statement, I don't think that makes sense. For most VRFs I've seen, I would say it's probably still fine to do it, right? Most of the air from these things are introduced in a way that is not blowing direct on people anyway. Most mechanical systems are designed that way. But I'll note too that there's the very famous restaurant in Wuhan back in, I think it was January, February. It was very well published. Basically had the same thing, a VRF that was just not ventilated, and it was just circulating the air like crazy, and that really did help transmit the virus in that particular restaurant. But again, if you have the ventilation air and the VRF is well distributed, it's probably fine.
Well, no, thank you so much for answering that question. And we'll, of course, want to be respectful of everyone's time. And so if there are no more other questions, I wanted to thank the panelists all for coming here today. Bruce, Stephen, and Bo, thank you so much for your time and your effort and your knowledge and expertise on this. And it still will remain a very relevant topic during and even after the pandemic, because schools will need all the renovations and the investment infrastructure that they can get.